Artificial intelligence, AI, refers to the simulation of human intelligence processes by machines, specifically computer systems. These processes include learning, the acquisition of information and rules for using it, reasoning, using rules to reach conclusions, problem solving, perception, sensing the environment and understanding it, and language understanding. AI systems are designed to perform tasks that would normally require human intelligence. They can analyze data, make decisions, solve complex problems, recognize patterns, understand natural language, and even interact with humans in a human-like manner. AI can be categorized into two main types. Narrow or weak AI. This type of AI is designed and trained for a specific task. It excels at performing that task, but its abilities are limited to that particular area. Examples include voice assistants like Siri and Alexa, recommendation systems on streaming platforms, and image recognition software. General or strong AI. This type of AI would have human-like intelligence and the ability to understand, learn, and perform any intellectual task that a human being can do. It would possess consciousness and the ability to reason across different domains. As of now, true general AI does not yet exist and remains a theoretical concept. AI technologies include machine learning, a subset of AI that involves algorithms that can learn from and make predictions or decisions based on data, neural networks, inspired by the structure of the human brain, used in deep learning, natural language processing, enabling machines to understand, interpret, and respond to human language, computer vision, enabling machines to interpret and understand visual information, and robotics, combining AI with mechanical systems to create autonomous machines. AI has the potential to revolutionize various industries, from healthcare and finance to transportation and entertainment, by automating tasks, improving decision-making, and creating new opportunities for innovation. However, AI also raises ethical and societal concerns, such as job displacement, bias in algorithms, privacy issues, and the implications of creating machines that can rival or surpass human intelligence. At a high level, artificial intelligence, AI, works by using algorithms and computational methods to mimic human intelligence and problem-solving capabilities. The specific workings of AI systems can vary widely depending on the type of AI and the tasks they are designed to perform. Here's a general overview of how AI works. Data collection. AI systems often require a large amount of data to learn and make informed decisions. This data can come from various sources, such as text, images, videos, sensor readings, and more. Data preprocessing. Raw data is often noisy, incomplete, or inconsistent. Before feeding it into AI algorithms, the data needs to be cleaned, transformed, and prepared in a structured format that the algorithms can understand. Algorithm selection. Different AI tasks require different algorithms. For instance, machine learning algorithms like decision trees, neural networks, and support vector machines are used for tasks like classification and regression. Natural language processing algorithms are used for language-related tasks. The choice of algorithm depends on the problem to be solved. Training phase. In the case of machine learning, AI systems go through a training phase where they learn from the provided data. During this phase, the algorithm adjusts its internal parameters to find patterns and relationships in the data. This involves minimizing the difference between predicted outputs and actual outcomes. Feature extraction. For tasks involving complex data like images or text, AI systems often need to extract relevant features or characteristics from the data that can be used for analysis. This is a crucial step in enabling the algorithm to make accurate predictions or decisions. Learning and optimization. AI systems learn by iteratively adjusting their parameters based on the training data. This process involves optimization techniques to improve the algorithm's performance over time. Inference or decision-making. After training, the AI system can make predictions, decisions, or classifications based on new, unseen data. For example, a trained image recognition AI can identify objects in new images it has never seen before. Feedback loop. AI systems can improve their performance through continuous feedback. If their predictions or decisions are compared to actual outcomes, they can adjust their parameters to become more accurate. Deployment and monitoring. Once an AI model is trained and tested, it can be deployed to perform its intended task in real-world scenarios. Monitoring the system's performance and making updates as needed is crucial to ensure its ongoing effectiveness. Iterative improvement, AI, is often an iterative process. As more data becomes available, AI models can be retrained to improve their performance. Additionally, researchers and engineers are constantly developing new algorithms and techniques to push the boundaries of AI capabilities. It's important to note that AI is a broad field with various subfields, including machine learning, deep learning, reinforcement learning, natural language processing, computer vision, and more. Each of these subfields has its own specific techniques and methods, but they all share the common goal of creating systems that can perform intelligent tasks. Artificial intelligence, AI, is used in a wide range of industries and applications to automate tasks, make predictions, improve decision-making, and enhance various processes. Here are some common areas where AI is used. Healthcare. Diagnosis and image analysis. AI can assist doctors in diagnosing diseases by analyzing medical images like X-rays, MRIs, and CT scans. Drug discovery. AI algorithms can help identify potential drug candidates by analyzing large datasets of molecular structures and biological interactions. Personalized medicine. AI can analyze patient data to create tailored treatment plans based on individual genetics, medical history, and other factors. Finance. Algorithmic trading. AI is used to make real-time decisions in trading based on market trends and historical data. Fraud detection. AI systems can identify unusual patterns in transactions to detect fraudulent activities. Credit risk assessment. AI analyzes financial data to predict creditworthiness of individuals and businesses. Retail and e-commerce. Recommendation systems. AI-driven algorithms suggest products to customers based on their preferences and browsing history. Inventory management. AI can optimize inventory levels, reorder points, and supply chain logistics. Customer service. Chatbots and virtual assistants powered by AI can handle customer inquiries and provide support. Automotive and Transportation. Autonomous vehicles. AI technologies like computer vision and machine learning enable self-driving cars to navigate and make decisions on the road. Traffic prediction. AI can analyze historical and real-time traffic data to predict congestion patterns. Logistics and route optimization. AI helps optimize delivery routes for efficiency and cost savings. Manufacturing. Quality control. AI systems can identify defects in products during the manufacturing process using image recognition and sensors. Predictive maintenance. AI analyzes sensor data to predict when machinery and equipment are likely to require maintenance, minimizing downtime. Natural language processing, NLP. Sentiment analysis. AI can determine the sentiment, positive, negative, neutral, behind text data to gauge public opinion. Language translation. NLP-powered systems can translate text from one language to another in real time. Voice assistants. AI-driven virtual assistants like Siri, Alexa, and Google Assistant respond to voice commands and perform tasks. Entertainment. Content recommendation. Streaming platforms use AI to suggest movies, TV shows, music, and other content to users. Game AI. AI can control non-player characters, NPCs, in video games, creating more challenging and dynamic gameplay experiences. Energy and environment. Smart grid management. AI optimizes energy distribution and consumption in smart grids. Environmental monitoring. AI analyzes sensor data to monitor pollution levels, climate changes, and other environmental factors. Security and surveillance. Facial recognition. AI-powered systems can identify individuals from images or video footage. Anomaly detection. AI can identify unusual behavior or patterns in security footage or network traffic. These are just a few examples of how AI is used across different industries. The versatility of AI allows it to tackle complex tasks, automate repetitive processes, and provide insights that were previously unattainable. As AI technologies continue to evolve, their applications will likely expand further, transforming various aspects of our daily lives and industries.